Hello, everyone. Hello. Okay, let's get started. Heading back to the computer. And I'm sorry, my TikTok has to be on the phone. For some reason, they won't let me do it on the actual computer. But I'm working on an idea. But for now, it's on my phone. Y'all can see it. Everything is good. So yeah, thank you so much. Okay. Alrighty, let us get started. So we left off here, and just to be clear, I noticed that everyone was okay. If you are not okay, just let me know. I have somebody on the chat as well that's helping me see who is asking questions, so don't stress about that. Okay, so we left off here, and our goal was to find the x-intercepts, right? And this part is actually not too bad. It's a bit of work, I won't lie, but once you get it, you're good to go. The first thing that you want to do is you want to check and see how many real zeros that you'll have, because when you're working with polynomials, you tend to find that you'll have some non-real zeros, ones that you can't really graph. This particular way of doing things is for you to figure out what zeros can you actually graph, or what intercepts are actually possible on your paper. And so to do that, all you need to do is figure out what sign changes are taking place. And so to do that, you just look at your equation here and you ask yourself, from this term to this term, did it go from positive to negative or negative to positive? Like, how did it go about? Right? And it looks like in this case, it went from a positive 2 to a negative 3. That's one sign change, right? That's one sign change. And then let's see, from negative 3 to negative 23, is that a sign change? No, it looks like it stayed the same, so there's no sign change here. And then from negative 23 to positive 12, that is another sign change. It went from negative 23 to positive 12. It's another sign change. So in your head, you should know that there will be at least, or at most, I'm sorry, 2 positive intercepts, x-intercepts. So you know that part. That's one thing less for you to worry about. Now, if you want to figure out how many negative intercepts that you'll get, same thing. However, instead of using a positive x, you're going to put negative in. So negative x, 2 negative x cubed minus 3 negative x squared minus 23 negative x. So I'm going to erase this so we have room. Plus 12. Okay. When you multiply that all out, you'll get a negative times negative is a negative 2x cubed. This is a minus 3x squared. This is a positive 23x plus 12. Okay, so here we do the same thing. And sorry, my screen froze, so let me fix it. Okay, that should be good. I'm sorry about that. So all I did, in case you didn't see, is I took a negative x instead. I put a negative x to see if there are any sign changes when there's a negative x inside my problem. So when I do that, I check again for sign changes. Negative 2 to negative 3, that's a no sign change. Negative 3 to positive 23, that is a sign change. Positive 23 to positive 12, no sign change. So now in your head, you have one negative potential intercept. Okay? So technically, you'll have 3 different zeros. That matches up. with what we started with. We have a degree of 3, we have 2 positive intercepts and 1 negative. Now let's figure out what the heck those are then. What are the actual numbers? So to do that, I'm gonna write down our notes here in our next thing. So just remember 3 possible x-intercepts. Actually, I'll keep it on the same page so we can just scroll down. Oops. Okay, still have these in sight. All right, so now we need to figure out, well, what are those zeros are? This is called the rational zero theorem. And all it says is, if you want to find all the possible zeros or x-intercepts of a polynomial. Does anyone know what it means? What happens? If you want to find all the possible zeros of a polynomial, what do you have to do? And if you don't know, totally fine. I'm here to tell you. So if you want to find all the zeros, all you do is you find the factors of the constant divided by the factors of the lead coefficient. P by factors of the lead coefficient. And this one is Q. So all it's saying is P divided by Q. So what did we say our constant was? Our constant is the number, it's the number that is on the very end. So this is actually our constant right here. We said our leading coefficient in the last experience was 2. So all we need to do is find the factors of 12 and the factors of 2. So let me scroll back down. Sorry, I'm having trouble here. So here, factors of 12 over factors of 2. And when we do that, you should get, what are the factors of 12? You can have plus or minus 1, you can have plus or minus 2, you can have plus or minus 3, you can have plus or minus 4. 5 is not a factor of 12. 6 is a factor of 12, plus or minus 6. 7 is not a factor of 12. 8 is not a factor of 12. 9, no. 10, no. 11, no. 12, yes. So these are your factors of 12. And then you're going to divide them by the factors of 2. And the factors of 2 should be just plus or minus 1 and plus or minus 2. That's it. When I say plus or minus, it means just the negative version and the positive version. I'm not gonna make you think too hard. You're gonna divide all of them. So plus or minus 1 divided by plus or minus 1, you'll get 1, and so on and so forth. So the final, when you divide all of these, the final answers you get are plus or minus 1, plus or minus 1/2, plus or minus 2, plus or minus 3, plus or minus 3/2, plus or minus, plus or minus 4, plus or minus 6, and the last one is plus or minus 12. So those are all of your, let me scroll down. Those are all of your potential factors of your polynomial, or your potential x-intercepts. That's kind of a lot, right? And we know we need 3. So from somewhere in these numbers, we have 3 intercepts that will work. This is where it gets fun. You now need to decide, what number should I start with? You can start with any number that you like. I'm gonna start with 1, because it's the one that's there. I'm gonna start with 1 and a -1. Let's do that. And so here, this is where the division comes in. Remember earlier when we did m squared minus 7m minus 11 divided by m minus 8? There's a reason for why we learned this. And I don't know if you remember, but I told you in there that we would have to, there's another way to divide polynomials, but we'll talk about it later, right? So this is the later. I'm now going to show you a different way to divide polynomials so you don't have to go through this particular process when it comes to finding zero. So let me show you. This way is called, I can't remember the exact name. I want to say it's, synthetic division. Yes, synthetic division. So synthetic division is what you use when you want to divide polynomials that have a certain format, okay? You can't always use synthetic division, and I'll let you know when. But all you need to know in this case is if 1 is a potential 0, we're going to use positive 1. You draw your little L shape like this. I'm sure you've seen it before. And at the very top here, all you're going to do is put your coefficients from your problem. So don't forget, our problem is what? Let's at the very top here. Okay, so our problem is this. So we have a 2, that's one of our coefficients. We have a -3, we have a -23, and we have a +12. So I'm going to take those and put them in my synthetic division problem. And I'll show you how I'm going to do that. So I'm going to take my 2, my -3, my -23, and my +12. Okay, I'll make this longer. Synthetic division is super simple. All you need to do is bring down your first term, which is 2, and then you're going to multiply across. Okay, so 2 times 1 ends up being 2. You put it right under the next term. And then you're just going to add down. -3 plus 2 is -1. Same process. -1 times +1 is -1. -23 plus -1 is -24. Same process. Multiply, 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 so you know. -24 times 1 is -24. And then you add down 12 plus -24 is -12. So if you end with a non-zero number, so this is not 0, then you can say in this problem, +1 as a potential x-intercept is not possible. So 0, so x cannot be 1 as an intercept. That's what this is saying. You can try another one. Let's try -1. So -1, same process. I hope you can see that. Same process with -1. You put our 2 across, -3, -23, and +12. Let's see. Bring your 2 down, multiply. 2 times -1 is -2. You add down, you get -6 or -5. Wait, 2 times 1 to make sure. Yeah. -5 times -1, you'll get +5. 23 plus 5 is going to be -18. And then -18 times -1, you'll get is +18. And then 18 plus 12, it's a pretty big number, right? 30. This too, so that means x cannot be -1 either. So we've tried 2 of them, they both don't work. The last one we're going to try is we're just going up the ranks, okay? So we did these ones, they did not work. Let's try +1/2. I'll put that over here, so we have room. So positive 1/2, same process, 2, -3, -23, positive 12. Let's see. Okay, so we bring that 2 down. 2 times 1/2 is going to be 1. -3 plus 1 is -2. -2 times 1/2 is going to be -1. And then -1 or -23 plus -1 is -24. And then -24 times 1/2, it's a positive 1/2, don't forget. We get, what is that? -12. 12 plus -12 is 0. We finally have a 0. Yes. So we can say, if we end with a 0, the x-intercept is correct. Meaning, we can say that x does in fact equal 1/2. That is one of our zeros. We have 1 down, 2 more to go. That was the hardest part, honestly, of the whole thing. Okay? It really was. Any questions? I don't think I see any. No, I don't see any. Okay, so I'll keep going. So what this is saying is that we have a x-intercept of 1/2. That means, I'm gonna go to my next page here. If we have an x-intercept of 1/2, that means we can write it as this, 1/2, 0, or we can write it as this, x minus 1/2 is also possible. I'm sorry, my face is big, so let me make myself smaller. Oops. I'll make myself that small. You don't need to see me that well. Plus, as my screen is frozen. Okay, so this is technically what we're saying. We have an x-intercept of 1/2. We can also write it as 1/2 comma 0. We can also write it as x minus 1/2, right? So when we do this, we can actually use long division again to figure out what we have left. So if we have x as 1/2, we need to figure out what it was divided by. And so we know that from here. Okay? And that is actually our dividend. So, or our divisor, sorry. So what it is, or this is our quotient, sorry, this is our answer. I'm so sorry. So our answer is hidden in these numbers. And you're probably wondering, well, what the heck do those numbers mean? I know we ended with 0. I thought that was it. But no, our answer is actually here. Our final answer, if we divide 2x cubed minus 3x cubed minus 23x plus 12 by 1/2, or x minus 1/2, we get 2x squared minus 2x minus 24. That's what these numbers mean. So this is actually your quotient. So if we go to the next page where I have this x minus 1/2, you could also say that we have an answer. When we multiply this, we got our full polynomial. I wouldn't stress too much about that. I just want you to know how you get the quotient from synthetic division. Because from here in long division, we had to do a bunch of math and we found that the quotient was n plus 1. What I'm saying is, in our problem, technically, if I want to show it to you better, what I'm saying is what we did technically without knowing is that we said x minus 1/2 divided by 2x cubed minus 3x squared, what was it? Minus 23x plus 12. What we're saying is that we did synthetic division and we found that our answer was 2x squared minus 2x minus 24. That's what I'm saying. Hope that makes more sense. Okay. So from here, we need to find the rest of our x-intercepts. Still very simple. We can find the rest from here. From this 2x squared minus 2x minus 24. We just need a factor, right? So to do that, 2x squared minus 2x minus 24. The first thing I'm going to personally do is I'm going to divide everything by 2. And the reason for that is because I'm seeing a common number of 2 between all of these. When I do that, I'll get x squared, negative x, and negative 24 divided by 2 is negative 12. Here's where you'll need to know how to factor, okay? So all we need to do is when you factor, we need an x here, we need an x here, and when we multiply the numbers in here, we should get a negative 12, but when we add them, we should get a negative 1. So we need something here that will get this. When we multiply them to get negative 12. So the best thing to do is just test some numbers. So negative 12 can be positive 4 and negative 3. Yep, that does equal to negative 12 if I multiply them, but if I add them, 4 plus negative 3 is not negative 1. So it can't be these two, okay? But I think we can probably do something in reverse based on what I just saw. We can do, what? Negative 4, positive 3? Because negative 4 times negative 3 equals negative 12. That works. And negative 4 plus 3, sorry, negative 4 times positive 3. Negative 4 plus 3 is negative 1. Yes, so x minus 4 and x plus 3 are also a part of our intercepts. But when you write these, don't forget, if our x-intercept at first was 1/2, and we wrote it as 1/2 comma 0, and then x minus 1/2, that means our other x-intercepts are going to be, so over here what I'm saying is that we have x minus 4, and our other x-intercept is x plus 3. How do we get there? All you need to do is set these equal to 0 and solve. So x minus 4 equals 0. Just move that 4 over to the other side. So that means x is equal to 4. Same thing here. You want to get x by itself. Subtract 3 on both sides. These cross out. So x is equal to negative 3. So our x-intercept is equal to 4, negative 3. How do we write that? 4 comma 0 as an ordered pair. Negative 3 comma 0 as an ordered pair. And if you wanted to write it as like a factor, the way I did earlier, we had it. So at the top here, it's x minus 4, x plus 3. Okay? So our final zeros are x, it's 1/2, 4, and negative 3. I'll write that at the bottom here. Oops, I keep writing the wrong thing. 1/2 comma 0 is 1, 4, 0 is another, and negative 3, 0 is another. And that lines up with our answer, right? When we were trying to figure out what our zeros were, we knew from the very beginning, we knew that we would have 3 potential x-intercepts, right? We knew that 2 had to be positive and 1 had to be negative. And that is all true here. We have 2 positive and 1 negative. So we know that we are completely correct. And now we can go ahead and draw our graph. So remember, I told you to draw our graph, we need 3 major things, or really 4 major things. The first thing we're gonna do is I'm gonna go to the next page and create some graph paper here. Let's graph this bad boy. And let's just plot our, what's it called? Our x-intercepts for. So we have a 1/2, a 4, and a negative 3. So on our graph here, this is 0, this is 1, that means 1/2 is somewhere in here. We also have a 4, so this is 2, this is 3, this is 4. You have one right here. X-intercepts go on the x-axis, don't forget. And then we have a -3, so -1, -2, -3. We have one right here. Okay, those are our x-intercepts. We have to also plot our y-intercept. What was our y-intercept? I think it was from a long time ago. Oh, here. So we found our y-intercept was 0, 12. So let's go plot that. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it only goes up to 10. Dang it. Let's just say it's up here somewhere. I'll put it at the very top. 12. Somewhere up there. Because my graph isn't big enough. And then this is where it gets fun. Remember at the beginning where we said we need to figure out the degree of where it will go? So we know that the leading coefficient is 2, so it's positive 2, so it will go up and to the right. That's because the leading coefficient is positive. We also knew that the degree is 3, so it will go opposite directions, meaning if the right is going up, that means the left side has to go down, right? So that means we know our end behavior of the graph going to the right. If I was to draw it, our graph is going up like this somehow on the right based on that, and then it's going down on the left because of that opposite effect. So we know the end behavior from the degree and the leading coefficient. But what is going on here? How do we know how to connect all the dots? That's not hard. All you need to do is, and I drew this line not very well, so let me draw it better, is we know somehow it's going down, right? So we just need to go through our x-intercepts. We go up to the y-intercept. We're gonna pass through, we're gonna go back down to our other x-intercept, and then go back up through our other x-intercept. So basically, you connect your graph based on all of your points. That's why it's very important that you get your x-intercepts correctly, but why you also need your y-intercept, which is somewhere way, way, way up there at 12. We just run out of room. So this is how you draw your graph. So if your teacher asks you, how do you draw this? 2x cubed minus 3x squared, what was it? Minus 23x plus 12. This is how you do it. How did we do it first? We found our y-intercept, which was 0, 12. We found our x-intercepts through a process, but we found that it was -3, 0, 4, 0, and 1/2. Those are the only real things you really need for or to draw a polynomial graph. Now, somebody had a question about domain and range. So domain and range on a polynomial or any type of graph, you're paying attention to the end behavior, where the arrows are going. So if domain, I'll go up here. Domain talks about left and right movement. So if you look at your graph, it's going left and right, right? And you can't really see because of the arrows are going up, but in your head you should think, okay, does my graph ever end? If I have arrows on the end, that means that this graph is going to go all the way up and to the right forever, and it's going to go all the way down to the left forever as well. So my domain for this graph, or on my x-axis, it looks like this graph will always go to the left forever and always go to the right forever because of these arrows. So you can say that your domain is all real numbers. You can write it like that. Or you can write it like this, negative infinity, which is all the way to the left, to positive infinity, all the way to the right. Similarly, with range, it's very similar. You want to notice up and down. So up and down. And you look at your arrows again. It looks like this graph is going to go all the way up forever as well. It's also going to go all the way down forever. It will never stop. This graph we only know where the cost of the x-axis and y-axis and stuff like that. So this too is also all real numbers. Similarly, you can write it the same. It's negative infinity to positive infinity. All right. That was kind of a long one, I know, but we honestly hit a bunch of topics. We hit how to name polynomials. We hit how to add them. So this is from the algebra section. So we learned how to name them. We know binomial now. We know how to add them. This is like terms and you combine them. We learned how to multiply polynomials. We learned how to divide them using this long division method. And then we also figured out how to graph them. We noticed it's kind of a process. We need to know leading coefficient. We didn't know the degree of the polynomial. We know that was 2 and 3 based on our problem. We found the y-intercept by plugging in a 0 for x. And then here is where it got really fun because we wanted to find the x-intercepts. We knew we'd have 3 potential intercepts because our degree was 3 of our polynomial. We found that we had 2 positive intercepts and 1 negative intercept because when we did the sign changes, we found there was a sign change twice when x was positive and there was a sign change once when x was negative. So that's how we got there were 3 potential answers, 2 were positive and 2 were negative. Then we went ahead and we did the rational zero theorem. This allowed us to figure out what exactly those numbers were. We found that all you need to do is divide the factors of the constant, which was 12, divided by the factors of the coefficient, which was 2. When we did that, all that division, we found that we had several potential zeros or several potential x-intercepts. We're like, whoa, how do we figure out which one to start with? We started with one end of the number list. We started with positive 1. We did synthetic division all the way down. I taught you that. You bring the first term down, multiply, add, multiply, add, multiply, add. And at the very end, if you wound up with a non-zero like this, you knew that x could not be that positive 1, right? So we moved on to the next one. We did negative 1. Same thing, pull down your first term, multiply across, add, bring it down. So when we did that, we found 2 here that because this was a 30, this is also a non-zero number. That means x cannot be negative 1 either, right? Then we did 1/2. When we did 1/2, we found we ended with a 0. If you end with a 0, and your brain should go off and be like, oh, that means 1/2 can actually be one of my x-intercepts. And a caveat here that I shared is that the answer you get, the numbers you get before the 0 actually balance out to your quotient or your answer when you divide. And I show that to you here. When you do the division of 1/2 from earlier, this is what I'm saying. You get 2x squared minus 2x minus 24. So I told you can write x-intercept in multiple ways. You can write it as x-intercept is equal to the number, which is 1/2. You can write it as a ordered pair, 1/2 comma 0. And then you can also write it as a factor of x minus 1/2. When we did that, we wanted to find the rest of our zeros. We knew that it was somewhere inside this 2x squared minus 2x plus 20 minus 24. We knew it was somewhere in there. To find that, we needed to factor and set that equal to 0. So this was equal to 0. When we factored, we found that x is equal to 4 here, because x minus 4 equals 0 made x equals 4, and x plus 3 equals 0 made x equals negative 3. So that means all of our x-intercepts were 1/2, 4, and negative 3. We went to go graph it. We only needed that piece of information. We needed our x-intercepts, our y-intercepts, and our end behavior, right? So if we have a positive coefficient, the graph will go up and to the right. If we have a negative one, it will go down and to the left, or just down in general, sorry. And then with your end behavior from the degree, that tells you even or odd. If you have an odd number, it is opposite directions of your end behavior. If it's an even number, they are the same direction. So that means that if I had an even number and my coefficient was negative, that means my end behavior means both sides of the graph will be down, down. But because one of them was odd and one of them was positive, we had down, up. Sorry, down, up. And the reason why we know it's down, up and not up, down is because the positive number tells you that on the right side, we're going up. So that's why it's this one and not this one. Okay, so once we draw our end behavior, we were able to draw the inside of the graph just by connecting all the dots. And the dots are simple. There are x-intercepts and there are y-intercepts. And they're signified here at -3, -3, 1/2, +4, and our y-intercept up here at 12. We ran out of graphing room, and that's totally fine, but this is the final graph of our polynomial. The last bit that we touched on here was domain and range. And so domain just talks about what is going on our graph from left to right. How are we moving? How is everything functioning? And we saw that based on the end behavior of our graph, the left and right, we have infinity. The graph goes on and on and on and on and on forever to the left, all the way to a negative infinity. And it also goes all the way to the right as well with a positive infinity. So in this case, you can either write it as all real numbers with this funky little r that I wrote up there, but most likely your teacher will appreciate you writing it like this, where it's negative infinity to a positive infinity. Similarly, we had our range. Our range talks about up and down movement, up and down of our graph. How far up does our graph go? How far down does our graph go? And it looks like in this situation, the arrows go up to forever as well. And it also goes down. We saw that here. So because of that, your graph goes to negative infinity all the way forever, and it goes to positive infinity all the way up to forever. So this is also a worthy answer for your teacher as well. All right. Let me check the chat and see if we have any questions. Let's see. All right, I'm not seeing any questions. Let me quickly check one thing though, because it looks like my screen might be, I'm gonna check TikTok. Give me 1 second. We only have 5 minutes. Okay, I'm looking at TikTok. Mimi and Javi, I think they're okay. I think they got all their questions. I don't see anyone else asking questions. So I think we're okay. Awesome. Cool. So we only have 5 minutes. So what I'm gonna do is I'm gonna call it a day. I think we hit on quite a bit. So what I would like you to do is, if you are not following me on Instagram, please go ahead and do that. Here's my profile. So you can follow me here on Instagram. Sorry, it's kind of hard to see, but this is SiSTEMtutoring.com. SiSTEM Tutoring. I'm the founder. My name is Pearl. We go live, as you can see, every week. So today is Monday, so we did algebra, and this session was supposed to be geometry and pre-cal, but we had some spillover into this session, and there's normally not a lot of geometry questions for some reason, but we do help with geometry and pre-cal. And then we also have chemistry and physics, and that takes place on Wednesdays at the same time. So if you'd love to join, please do that. You can follow me on Instagram. You can also follow me on TikTok as well, if I can find it. I don't know if this is my TikTok. It might be my personal one, I don't know. Oh, whatever. But I am on TikTok. So if you want to find me on TikTok, obviously follow me here if you're on the live. And so, yeah, I love working with students. I love helping. And so if you have any questions or you want me to address any of your problems next week at the same time, I'll be available at 4:30 PM CST. And you can shoot me an email to here. Let me show you here. Shoot me an email at homework@SiSTEMtutoring.com. All right. Thank you everyone for coming. Thank you for staying interacted and fun. I had a great time. So please tune in on Wednesday if you need help with chemistry and physics, or next Monday I will be available to help with algebra and pre-cal and geometry and all that fun stuff again. So again, thank you.